Picture this. It's the night of October the 19th, 2017, and Canadian astronomer Robert Weryk is conducting routine observations at the Pan-STARRS 1 telescope perched high atop the Haleakala volcano on the Hawaiian island of Maui, 10,023 feet above sea level, where the thin air provides crystal-clear views of the cosmos. As he reviews the night's data from this state-of-the-art facility, operated by the Institute for Astronomy at the University of Hawaii, something extraordinary catches his eye. A faint streak of light moving at an impossible speed of 196,000 miles per hour through our solar system. Too fast to be bound by our sun's gravity. What Weryk had discovered would ignite the most intense scientific debate of the 21st century, divide the astronomy community into warring camps, and force humanity to confront the possibility that we are not alone in the universe. This is the story of Oumuamua, the mysterious interstellar visitor that arrived from the depths of space, carrying secrets that still baffle scientists today, in 2025, 8 years after its dramatic discovery. Let me take you back to that pivotal October evening in 2017, when the scientific world was about to be turned upside down by a discovery made from one of the most remote and pristine observing sites on Earth. The Pan-STARRS 1 telescope, short for Panoramic Survey Telescope and Rapid Response System, sits like a sentinel on the summit of Haleakala, a dormant shield volcano whose name means House of the Sun in Hawaiian. This isn't just any telescope, it's a cosmic early warning system designed to scan the heavens for potentially dangerous near-Earth asteroids, equipped with the world's largest digital camera capable of photographing 3 billion stars and galaxies in a single image. But on October 19, 2017, as Robert Weryk analyzed the telescope's automated survey data, he spotted something that defied every expectation. An object designated A/2017 U1 that was moving far too fast to belong to our solar system. Within days, as observatories around the world swiveled to track this cosmic intruder, the shocking truth became clear. This visitor had already made its closest approach to our Sun 40 days earlier on September the 9th, racing past at a mere 23 million miles, and by the time humanity noticed it, the object was already 21 million miles from Earth and accelerating away at breakneck speed toward the constellation Pegasus. The International Astronomical Union was so stunned by this unprecedented discovery that they created an entirely new classification system for interstellar objects, designating it 1I/2017 U1, the 1I marking it as the first confirmed interstellar visitor in human history. The Hawaiian Discovery Team chose the name Oumuamua, meaning a messenger from afar arriving first, a prophetic choice that would prove more accurate than they could have imagined. But even as the world celebrated this historic first contact with an object from another star system, the real mystery was just beginning to unfold. The implications of Oumuamua's discovery sent shockwaves through the scientific community because it revealed something profound about our place in the galaxy. We are not isolated. Our solar system is regularly visited by travelers from distant stars, cosmic wanderers that have journeyed for millions of years through the void between worlds. Over the following months, more than 800 observations were made by telescopes across the globe, each measurement adding new pieces to a puzzle that would ultimately divide the scientific world and capture the imagination of millions. As the world's most powerful telescopes focused on Oumuamua during its brief passage through our solar system, the data that poured in revealed an object unlike anything astronomers had ever encountered. NASA's Hubble and Spitzer telescopes revealed that Oumuamua possessed an oddly elongated, cigar-like shape between 100 and 400 meters long, making it roughly 10 times longer than it was wide, a geometry so extreme that it was virtually unprecedented in our solar system. As this cosmic cucumber tumbled end over end through space, rotating every 7.3 hours, its brightness varied by a factor of 10, creating a mesmerizing light show that revealed its bizarre silhouette against the stars. But it was the object's reddish hue that first hinted at its incredible journey. The surface appeared reddened due to the effects of irradiation from cosmic rays over hundreds of millions of years, suggesting that Oumuamua had been wandering through interstellar space for eons. bombarded by high-energy particles that gradually altered its chemistry and appearance. This ancient wanderer carried within its structure the accumulated history of its journey between the stars, a cosmic time capsule that had witnessed the birth and death of solar systems across the galaxy. Then came the observation that would ignite one of the most heated scientific controversies of modern astronomy. As Oumuamua sped away from the Sun, something unexpected happened. It sped up slightly as it left our solar system, receiving a mysterious boost in velocity that couldn't be explained by gravitational forces alone. This non-gravitational acceleration was subtle but unmistakable, detected through painstaking measurements by NASA's Hubble Space Telescope that tracked the object's position with extraordinary precision across multiple observations. In our solar system, such acceleration is typical of comets, whose icy surfaces sublimate when heated by the Sun, creating gas jets that can push them slightly off their predicted gravitational trajectories. But Oumuamua showed none of the telltale signs of comet activity. No tail, no coma, no detectable outgassing that telescopes could observe. It looked like an asteroid, but behaved like a comet, creating a paradox that stumped the world's leading astronomers and opened the door to increasingly exotic explanations. Initial analysis suggested it was dense, composed of rock and possibly metals, with no detectable water or ice, making its comet-like acceleration even more mysterious and inexplicable. The mystery deepened when scientists tried to determine where Oumuamua had come from and where it was going. Its hyperbolic trajectory suggested it had been traveling through interstellar space for millions of years, but its precise origin remained frustratingly elusive. Computer models traced its path backwards through space, but the uncertainties in its motion made it impossible to determine which stellar neighborhood had been its home or how long it had been wandering between the stars. The inexplicable acceleration of Oumuamua unleashed a torrent of scientific speculation that ranged from conventional to controversial to absolutely extraordinary, splitting the astronomy community into fierce debates that continue to rage in 2025. The leading mainstream theory emerged from years of careful analysis and was published in the prestigious journal Nature, proposing that Oumuamua's mysterious behavior could be explained by hydrogen outgassing, the slow release of hydrogen molecules trapped within the object's ice as it warmed near the Sun. According to this theory, cosmic radiation had been cooking the interstellar traveler for millions of years, gradually forming hydrogen gas within its structure, which then escaped as invisible jets when heated by our Sun, providing just enough thrust to account for the observed acceleration without creating a visible comet tail. This hydrogen iceberg hypothesis gained significant support in 2023 and was further refined in 2025, with researchers arguing that such dark hydrogen ice compositions could be relatively common among interstellar objects. The theory elegantly solved the Oumuamua paradox by explaining how the object could behave like a comet while appearing like an asteroid. The hydrogen outgassing would be virtually invisible to our telescopes, but still powerful enough to alter the object's trajectory in precisely the way observed. But not everyone was convinced by the hydrogen explanation. Critics pointed out that the theory required very specific conditions and compositions that seemed almost too convenient, leading some scientists to propose alternative scenarios. Some researchers suggested that Oumuamua might be a fragment of nitrogen ice, similar to the surface material found on Pluto, that had been ejected from a distant planetary system. Others proposed that it could be composed of exotic materials created by the extreme conditions found in the space between stars. Then came the theory that captured headlines around the world and divided the scientific community like no discovery before it. In 2018, Harvard astronomers Avi Loeb and Shmuel Bialy published a groundbreaking paper suggesting that Oumuamua's acceleration could be explained if it were not a natural object at all, but rather an artificial construct, essentially alien technology. Loeb argued that the object's properties were consistent with a light sail, a thin sheet of material designed to be pushed by solar radiation pressure, and he continued to defend this possibility even as recent studies provided more conventional explanations. The alien technology hypothesis sent shockwaves through both the scientific community and popular culture, with Loeb arguing that the scientific establishment was too conservative and close-minded to seriously consider the possibility of extraterrestrial artifacts. He pointed to Oumuamua's extreme elongated shape, its unusual acceleration, and its lack of visible outgassing as evidence that it might be humanity's first encounter with technology created by another civilization. While most astronomers rejected this interpretation due to lack of supporting evidence and the availability of more conventional explanations, the debate highlighted fundamental questions about how science should approach truly anomalous observations and the possibility of discovering evidence of extraterrestrial intelligence. As we stand here in September 2025, nearly 8 years after Oumuamua's dramatic discovery, the mystery of our first interstellar visitor continues to generate new research and heated debate. The discovery of additional interstellar objects, including 2I/Borisov in 2019 and 3I/Atlas, discovered on July 1, 2025, has provided crucial context for understanding Oumuamua's unique properties, but it has also revealed just how unusual our first interstellar visitor truly was compared to its more conventional cousins. Recent developments have added new layers to the Oumuamua enigma. The latest research published in 2025 by astrophysicists affiliated with the University of Chicago has strengthened the hydrogen ice hypothesis, arguing that outgassing of hydrogen provides a simple and elegant explanation for the object's mysterious acceleration. These studies suggest that Oumuamua represents a new class of interstellar objects, essentially invisible hydrogen icebergs drifting through space, occasionally illuminated when they pass close to a star. But the hydrogen theory faces ongoing challenges and criticism. Some scientists argue that hydrogen ice would be extremely difficult to maintain over the millions of years required for interstellar travel, as it would gradually sublimate even in the cold depths of space. Others question whether the proposed mechanism could produce exactly the right amount of acceleration observed without creating detectable emissions. The debate has become so intense that it has spawned entire conferences dedicated to understanding Oumuamua's properties and implications. Meanwhile, the search for similar objects has intensified dramatically. Advanced surveys like the Vera C. Rubin Observatory's Legacy Survey of Space and Time, which began operations in 2024, are expected to discover dozens of interstellar visitors over the next decade. Each new discovery provides an opportunity to test theories about Oumuamua and determine whether it was truly unique or representative of a larger population of interstellar wanderers. The technological implications of Oumuamua's discovery have also spurred innovation in space exploration. Scientists are developing concepts for rapid response missions that could intercept future interstellar visitors, potentially launching spacecraft within weeks of discovery to study these cosmic messengers up close. Such missions could finally resolve the debates surrounding Oumuamua by providing detailed chemical and physical analysis of similar objects. Perhaps most intriguingly, Oumuamua has forced humanity to confront the possibility that interstellar space is far more populated than we ever imagined. Statistical models suggest that at any given time, there could be thousands of similar objects passing through our solar system undetected, most too small or dark to spot with current technology. This raises profound questions about the nature of planetary system formation and the exchange of material between stars across the galaxy. The story of Oumuamua represents far more than just the discovery of an unusual asteroid or comet. It marks humanity's first confirmed encounter with a traveler from another star system, and our first glimpse into the vast network of matter that flows between the stars across our galaxy. Whether it was a hydrogen iceberg sculpted by millions of years of cosmic radiation, a fragment of an alien world ejected by some cosmic catastrophe, or something even more extraordinary, Oumuamua has fundamentally changed how we view our place in the cosmos. The debates surrounding Oumuamua have revealed important truths about the nature of science itself. The willingness of researchers to consider exotic explanations, including the possibility of alien technology, demonstrates the healthy skepticism and open-mindedness that drives scientific progress. At the same time, The eventual convergence toward more conventional explanations shows how the scientific method gradually filters speculation through evidence to arrive at increasingly robust theories. But perhaps the most profound legacy of Oumuamua is the questions it has raised about what else might be out there. If interstellar objects regularly pass through our solar system, what other mysteries are drifting through the darkness between stars? Could some of these visitors carry organic compounds or even primitive life forms, seeding planets with the building blocks of biology? Are there other artificial objects floating between the stars, waiting to be discovered by future generations of telescopes? The next time you look up at the night sky, remember that right now, invisible visitors from distant stars may be passing through our cosmic neighborhood, carrying secrets from alien worlds and distant eras of galactic history. Oumuamua was just the first that we managed to spot and study. But it won't be the last. As our technology improves and our surveys become more comprehensive, we will undoubtedly encounter more of these interstellar messengers, each carrying its own mysteries and revelations about the dynamic, interconnected nature of our galaxy. What do you think Oumuamua really was? A natural hydrogen iceberg shaped by eons of cosmic wandering, or something more extraordinary that we haven't yet learned to recognize? Will future interstellar visitors provide the answers we seek, or will they only deepen the mystery of what lies between the stars? Share your thoughts in the comments below, and don't forget to subscribe for more cosmic mysteries that challenge our understanding of the universe. The age of interstellar archaeology has only just begun, and the greatest discoveries may still lie ahead in the darkness between worlds.